Welcome to another episode of Cloud Unplugged. We have 4 stories today, news stories, in obviously the technology space as always. We have Lewis CoreWeave's big IPO, 35 billions valuation, which we'll come on to. We've got Amazon have launched some new features called Amazon Transform, plus there's an open source called StreamYard, but we'll come on that for agents. But they can now help you transform all your legacy apps into more modern code bases and
Single
PaaS
shot.
services.
Just say
We have Grok 3 is now on the Azure AI Foundry. They made that available as one of the models. And something we don't really know that much about, but we're going to try and talk about anyway, which is quantum computing and ABCIQ supercomputer in Japan and Nvidia's investment in that with Advantage 2. I think the company is called D-Wave. But before we get into them, how have you been, Lewis?
I've been good. I went surfing at the weekends. So another non-tech
Non-tech again.
Although maybe AI did come up and we had some conversations, but I saw a couple of good friends in Bristol and got to go surfing.
Did you master it? Are you
weirdly enough,
waves?
Last time I went surfing, it was a little bit choppy. And I thought, I can only surf on an artificial wave. But this time, you're looking at a surfer.
Oh, really? Well done. You can do it.
Surf.
How long's that taken?
It took quite a few sessions and the conditions were kind of perfect. So let's not get ahead of ourselves. I can go in a straight line off a baby wave.
That's good. That's really good. How long did it, do you reckon, did it take? Hours wise, if you were to have condensed it all into hours.
If I condense it all down into hours, it's a maybe I don't know, a full day of flapping around, but you never get it in a day because conditions and tiredness and things. So I'd say you need a week, or I would need a week to learn surfing. But
cool, that's very good. It is very good. And did your friend surf as well really well?
He can bib and bob around.
He can bib and bob. That's a no. It's just basically just a no, isn't it?
I don't know.
Throw your friend under the bus there. Absolutely.
It's anonymous. It's fine. How did your weekend go? Anything interesting?
Just bits and bobs. It was very hot, wasn't it, here in the UK on Saturday? So that was good. And then a bit of the usual stuff, exercising. I went out for dinner. Nothing really, pretty chilled. But yeah, nothing particularly exciting. Just kind of like domestic things and a bit of work on the side. But nothing really very exciting. And then just as usual, went to the gym this morning. I had somebody get very angry at me this morning in a car.
Were you cycling?
I was just No, I was just crossing a zebra crossing, which here obviously in the UK is you have to stop for. And then he basically, obviously I was just waiting. And then he went over this after a cross, just kind of like went through the zebra crossing, and then went, "Thank you very much," like that. And I was thinking to myself, and then obviously started some, I think he called me a dickhead or something. But I'm like, it's a zebra crossing, of which you're supposed to legally stop so someone could cross. So it was a bit weird. It's obviously I was supposed to thank him for stopping, like paying for your food in a supermarket, which is obviously expected, and then being like, "Thank you very much." You know what I mean? I paid. Do you know what I mean? Like you're doing them a favor or something, and it's like, yeah, that's kind of the rules.
Well, the takeaway is that you've got a better, sunnier disposition than this poor person. Let's make him the poor person.
Just very strange. There was only me and this car on the road as well, so it was like, because it was super early. So I just thought, what a bizarre thing. Anyway, so yeah, I had that this morning, which obviously started the day a bit like there's a lot of ag in London this morning, so it seems. And I'm a little bit hungover, so Yeah.
That might have contributed to your perception.
Maybe I just walked out in front of his car in a hungover state, and actually it was legitimate. And it's like had to break really quickly. In my world, it wasn't like that at all.
You
Yeah,
look both ways. Green cross code. I'm on a
exactly. I was
crossing.
perfect, but
Of course.
really, exactly. So anyway, let's get into these stories. CoreWeave, obviously, this is something you were kind of rifted on around. The big valuation used to be cryptocurrency mining company, and then obviously has started to specialize in GPU and AI workloads, due to obviously them using that technology to do the mining. What do you think about it? 35 billion valuation in this year, 2025.
A very, very small company. Well, a very, very recent company, 2017.
2017, yeah.
Doing crypto mining. And then 2021, I think, if I remember rightly, not very long ago, or maybe 2019, some not that long ago. The crypto mining space is obviously extraordinarily volatile, and there was a switch in. It's all going out of my head. There's There's Bitcoin, and then what's the other the bigger cryptocurrency that switched from proof of work to proof of stake, which kind of took the wind out of some of their pure compute play for crypto mining.
I actually really don't know what you're saying. I actually don't understand. What do you mean? The proof of work to a proof of state?
So crypto mining, cryptocurrency is based on doing vast amounts of computation to prove factorization of prime numbers effectively. It's like cryptography itself.
The cryptocurrency.
It's very easy to prove that the work's been done, but it's very hard to do the work in the first place.
Yeah.
So it's perfect for storing on a blockchain and saying, okay, all the transactions are stored, we know what's going on, but you've got to do an extortionate amount of compute to prove that next token, if you will, that would be presentable on the blockchain. So that's called mining, and that's highly contentious because arguably you're just doing maths and heating up the planet and using all the power for an arguable IOU sort of use case when money already exists. But there's other ways of sort of using cryptography to record something to other than the actual work itself, to make that more efficient.
And that made them 35 billion. How?
So they were sitting on a whole bunch of hardware for they were using Nvidia chips, the latest, greatest, and they had a competitive advantage when mining cryptocurrencies if they could just have the latest chips at all times, because then they can mine the most money effectively. If there's an exchange rate for the cryptocurrency you're using, you can cash it in. So you literally mine for money by using Nvidia. But as time's gone on, AI has become a thing, and they were already scaling Nvidia pure play computing platforms and data centers. So they found themselves at the right place at the right time to take advantage of a newer, better, and in some ways slightly less contentious use of their data centers. And I think 60% of their revenue comes from Microsoft, and Microsoft clearly have arrangements with OpenAI and are riding the AI wave at the same time. So it's interesting, and I think inference for AI is probably a much better use than doing maths to secure value.
Well, you're making money through the computation aspect directly, isn't it? It's like compute.
Absolutely, at least
they're selling the compute for other people to make money.
Absolutely.
Model,
yeah. So I
So
think
I know that Nvidia have got like 7% investment in CoreWeave. I think they managed to secure it as part of the IPO. So they do. I was reading about this, about how they basically get access to all of the latest Nvidia chips. So quite cutting edge, which is obviously quite good. But
I do.
and then
I
also,
do.
yeah.
Sorry, no, you were saying and also.
Yeah, I was just going to say, and then also there was a deal with OpenAI as well, 11.9 billion deal, which is mental. And obviously also interesting because you'd expect the Microsoft relationship with OpenAI that they would obviously just use Microsoft. So there's obviously a need to, like, there's so much compute needed for OpenAI, even to the point where they're kind of surpassing Azure's capability for it. And obviously maybe given the fact that you don't really want OpenAI eating all the compute of your customers' work, kind of GPU needs. So it does kind of make sense that they diversify out as a service to use something else. So that was quite good.
It's funny trying to work out how much of a diversification from Microsoft, who are using compute for hosting OpenAI, to OpenAI Direct for hosting the models or training the models. I don't know. It's an interesting play. I guess at the moment they're making a net loss in 2024 of nearly $1 billion, 863 million. So I guess time will tell. There's a lot of interested parties and a lot of people wanting their compute regardless. So I don't think they'll go under, but also it does feel like well, I hope for their sake it's not the next WeWorks evaluation and loads of investment forever and never turning a profit. They're slated to maybe turn a profit by 2029.
But they must be able to turn it. It must surely, if they've had an 11.9 billion investment from OpenAI, then obviously that's an investment.
I guess
it's a contract, isn't it? They've basically got a commercial deal over several years. So that's obviously going to add to their revenue.
I think the bottom line and part of the business model is to continue growing. And effectively the investment by parties that just need the compute, whatever, they've already securing it. And part of the business model is actually to secure investment to build AI hardware on demand. So they've got very advanced data centers with water cooling, InfiniBand, and all the things you need to just have GPUs in a data center running as large as you can go. But you kind of, what part of their business model I was reading was securing the investment to grow the data center. So it's kind of net loss on year, but net growth in valuation and continued custom. So it's too early to say, but yeah, interesting.
That is interesting.
The demand in this space is just constant growth, and now the pure play providers.
Yeah, I think they've got. I was reading about they've got like very low latency InfiniBand, or obviously like the transmission of the data of such a low level that to the models and to models training on the GPU. So obviously it's like very, very quick. I've not actually used it. Never really used. Have you used CoreWeave?
No, I hadn't really heard of them because they're obviously a couple of removed from normal consumers. Their customers are cloud vendors and people needing to host model training and model inference, and their hardware just fits. I guess most of the cloud computing, I guess the interesting thing is here is the cloud platforms hosting their own models and their own progression in AI, but also potentially brokering other service providers who host their own training and hardware. I guess there's other news that touches on this as we move forward from the other stories.
Interesting. Yeah, I know they do have the SaaS offering, and they've got like fully managed Kubernetes. I know you can kind of sign up. Because I kind of remember reading about that a while back there.
Mm-hmm.
The cubes.
Yeah, it does feel like
old
Cubers is quite relevant when the main workload is kind of thin and stateless, and the thing that you're working on, you need as many GPUs as possible, so you just need to keep connecting to loads of nodes. So yeah, interesting.
And then Amazon, they've launched. This is kind of interesting because there was a pitch recently that we were part of on Amazon were kind of pushing their partners to use a product called vfunction, which basically does exactly what this does, and it takes legacy apps, kind of analyzes the code base, starts to document the business logic, tries to understand the business logic, and starts to write the code, in the more modernized code based off the legacy system. And then literally that was maybe 2 weeks ago, or maybe it was even last week. And then AWS Transform came out, which is their own service that does exactly what they were telling their partners to use as one of their partners, vfunction partner. So it's kind of interesting. So it does look really, really good, as in like on paper, claims, and these are the big claims, that it has 90% code accuracy. I think in some cases it's saying it has 100% accuracy. These are the claims. And it uses a graph neural network with the LLM. So it starts mapping the relationships between everything and going through the code base. Apparently quite accurate, so it says. And it's 4 times faster than you trying to do it on your own and trying to rework it all. And it has human in the loop. So basically you can approve the things it's coming back with and, explain whether it's good. It will even provision things for you. It'll write the CloudFormation for you. It will go and afterwards go and host the app for you. So obviously there's a big play on, all these big legacy apps that are in these companies that no one ever dare even think about trying to start that project. It's written in COBOL, and people are retiring who know COBOL. And understand the logic, and they're like, obviously more and more risk in businesses, like, actually we just need to get this done. So it is quite a good move, I think. What are your opinions?
Yeah, I agree. It's a good move to start to address, but I think it kind of shows the approach when you're faced with this whole rise of agentic AI. You're going to quickly flowchart N8 and Vertex AI or whatever. You're going to just quickly flowchart up an agent flow, and all your business problems are solved. I think the devil's in the detail and having the right type of model.
No, it's 100% code accuracy.
100%. Oh, you're right. Yeah, sorry.
It's actually
done.
Let me give you a couple of details. 4 times faster and 100% code accuracy. There's a couple of details for you, Lewis.
Well, they also said 90% code accuracy. So
if we're splitting hairs,
choose one.
Maybe 90%. Yeah.
I guess the point I'm trying to make is like trying to make your own agentic flow without using the right type of model, whether it be an LLM or whether it be a tool or whether it be a combination of specifically trained networks. I mean, I think the graph neural networks that they're using as part of this service to train on a hierarchy or a graph, a tree of all the related nodes of connectivity between pieces of code and the layout of code repositories to pieces of infrastructure and how that software architecture needs to be hosted and communicate, and therefore what you need to wrap it in and how you need to rehost it is fascinating. I imagine, like, in the the devil that I speak of will be actually getting this end-to-end story, like, to apply to your business logic when there's hidden blobs, compiled, binaries with no source available, and all sorts of mess that's going to exist, and sasses and other bits of hidden functionality which aren't privy to the model. Yet human in the loop is going to be key to, like, no, you can't just infer that, or those docs were made up, or that person left and that was the intention of the spec doc there, but it's actually just a stub, and that was a version that wasn't finished, and we never used that bit of code. All this type of reality would, make the actual problem in reality harder than this conceptual. But I don't doubt for a minute that it would speed things up drastically, and a highly specific agentic flow written by Amazon has a much better chance than businesses trying to cobble together a sort of let's do this for code. And given a very specific output of a very specific set of frameworks and hosting options, and a very specific set of hosting options and frameworks that they're going from, there's a chance, isn't there, that it could join them up.
Yeah, I think it's their own model. So I don't think it's like they're not using some generic model. I think it's like their own trained model under the hood on the code bases. So
they're using bedrock models. So they've got their own trained models for bits of the puzzle, LLMs for other bits of the puzzle, and their own, graph neural networks specifically.
You've got their own graph neural networks,
yeah. Where they're trying to work out relationships. So yeah, it's all, and it's an agentic flow over the top to wire together each of these models
exactly, to do
in a flow. So it's not like one model does it.
Exactly, which does make a lot of sense. So it sounds like it'd be much more effective. Yeah, very, very interesting. And they also came out with an open source SDK for generating agents, AI agents, basically like a one-liner to bootstrap a agent. Very, again, wedded to the Amazon ecosystem. So, can obviously leverage like you're just saying, the bedrock model. So basically all the different models, Claude and Grok and etc. I can use them on
Grok.
Bedrock.
Well, if
Grok is in the Bedrock.
Is it now? So a recent announcement was Grok was just released for use with Azure in AI Foundry.
Yeah, but that's because they were like slow to the table. It was already in Amazon.
It's not available on GCP, but I didn't realize it was available on Amazon. I did a report and find out which ones are available, and Grok wasn't on the report, but obviously LLM training and what they're giving me without doing deep research. But it is an interesting topic where the models are available.
Yeah, I'm pretty sure it was in there because there was some blog by Amazon somewhere around Grok. I could be wrong, but I'm pretty sure I saw something. But people can tell me I'm full of shit, I suppose. Maybe I'm just like I am the AI. I just hallucinate and make things up. That's the way to be. But yeah, anyway, getting back to the Strands agent, which is the open source, open sourced a way of you quickly creating a new agent, and you can put the tool integration in there, so you can obviously integrate into third parties, and they've got a loop handling, so you can go off and do things and get the output and feed it back to your agent. And believe it or not, you can deploy it, and this is going to really surprise you. You can deploy it in Amazon afterwards. You can use this open source Amazon created project, and weirdly, it also supports deploying that thing into Amazon.
Do you know what's fascinating? The cost of using this framework and the agents is free, but hosting things on Amazon isn't.
Yeah, that's a little
it's kind of a little bring all your stuff into our cloud. We make it super easy. No cap.
Exactly. So it's good though. I mean, I do like it because it does make producing agents much easier. Going to be very, very interesting next few years, isn't it? With all these, MCP servers coming out, and how quickly it is to build an agent. The agentic flows, like basically, obviously, flowing from one agent to another. to kind of string things together, a workflow together, or an outcome together. I'm just talking about. So there's going to be so much innovation, isn't there? Really, it's going to be insane.
In general business process, it feels like reducing hallucination is key, and testing that is hard. But with highly specific agents that do one bit well of a process and then linking them up, and I think with code, ironically, it's at least there's really strong signals of whether it compiles at least. So there are some stronger indications that code in AI is one of the first things to show real benefit. So
yeah, it's mad. What are your views? Because you've already kind of touched on this. You're saying that the Grok 3 announcement now on the Azure AI Foundry, which is an equivalent to basically Amazon's Bedrock, essentially, isn't it? A list of the models available.
That's right. I mean, I found, because I researched this specifically.
Oh, you're saying I didn't? I don't research that. That felt like a really
I wouldn't
aggressive.
Wouldn't be that cool. But let's just put it down to the fact that you were out last night and today's hard.
And almost got run over today. Yeah, fair.
So what I found was that Microsoft were first with getting Grok. Grok's one of many models, and I think the important thing is each cloud provider has very specific models, foundational models that are good at very specific things, and they host, and you get access to the AWS models through AWS and through GCP through the model garden. You get access to all the Gemini models and the latest VO models, so the image generation models, and the video generation models, and their audio models. So each cloud has got different specialities and different training, and I'd say GCP is very much at the forefront of some AI research, but they realize they've got to democratize it to give all the Llama models and all the other, and bring your own models. And so to each cloud provider has got a slightly different shape of how this all fits together. But I guess it's too early to say how this all links up, because with things like agent-to-agent protocol, where you host things and which models you use at which costs. I mean, sounds like a job for an agent to work out where the best, where to run all the agents are, and which models and which bits do which bits of the problem.
There's got to be new. There's going to be quite a lot of new standards surely coming out. Like agent to agent, like maybe even new RFC standards. DNS. I think I was reading something about DNS for agents, for discoverability of agents. And actually thinking through how an agent can actually discover other agents. And
this is like what was the name for the web? You have a semantic web, and it was all going to be based on XML, and it was all going to change the world, because the computers would then be able to look up all the other web services, and how it was web services, wasn't it, with XML? Back in the 90s. No.
Yeah,
it was like, this is how we're going to connect up the web, because the web will understand how to connect the web up, but you kind of need a bit of intelligence on top of that, and it's kind of playing full circle. Now you need some documents written in English that AI models can read, understand how to use, but they've got more power than a fixed JSON schema. It's more of an open, these are the capabilities and these are the blobs that you can stick things in as you move your context around. So fascinating times. And
I think the barrier for entry is dropping, isn't it? So you don't need to. I mean, even if you can create an agent that's very specific, you want to do a very specific thing, like you're saying. And now there's all these different types of models that have different advantages, and you can basically figure that out. Grok for more research-based stuff, potentially scientific research, data, web citations, live data, basically. then I guess if you have access to all the different models for your agent to then leverage, and like you're saying, you can then choose exactly the right one for that job, and it only does one job. That's the point.
Mhm.
And then you can quickly go and write another agent really fast, because now you just bootstrap it using StreamYard. And that's got a different model maybe behind the scenes, because it's more suited. And then that does that specific job. And then you chain those jobs together and you get into the agentic flows, which is what you're talking about. Then before you know it, you've managed to really probably not write much code, and potentially give very good answers or very good results to whatever it is you're trying to do, plus then hook it into your tools, so things you might want to run, constrain the output so you can check and qualify, like, if it's not really like this, it's probably not a good answer. So you don't give silly answers that, it's made up. And you can kind of filter those things. And you've kind of constrained it. So you're like, well, actually, the probability of it making a mistake is really, really low. And you've got a really neat little service. So when you're writing one,
I'm just finishing one now. In fact, this is one.
oh wow, it's this one, is it?
This is just a bunch of agents.
You are
taking some flow, generating some images,
wow,
listening, going down some deep research. I can seem really clever, but actually, just generating.
You are really just an AI generated Lewis.
Yeah,
wow,
it's basically my avatar. It's an avatar that's generated on demand, listens to your voice, it goes off, it uses a bunch of protocols to talk to different agent services. They run tools, they have access to the web, and it comes back and I hallucinate all this rubbish.
I was thinking, because I was like looking and I was like, I don't think you are real. Because that hair,
it's just pixels.
Very.
I do need a haircut. This weekend will be the haircut. That's better. No hair. God, I look like my brother. My brother's got no hair. But,
oh really? Your brother's got no hair.
Yeah,
well, he could halve your hair and probably post it off to him.
There's enough hair to go round. That's what we're saying. Looks like.
Or get an AI for your brother that has hair, an avatar for your brother with hair. Maybe that's the way to go.
That's the solution. That's the thing.
The next thing we're going to talk about, which this is where I am slightly out of my depth. I'm not going to even pretend. Not like I've pretended at all anyway on how little I know. But the quantum supercomputer, ABCIQ, which is a Japanese supercomputer for HPC, essentially, isn't it? Supercomputers. Nvidia is obviously investing, and I think they're leveraging D-Wave's advantage to basically
two separate
generation
investments.
But
ABCIQ is one thing that happens to use Nvidia, but Nvidia are also investing and partnering with D-Wave. Two separate things.
Yeah, separately. Yeah, they're investing everywhere. So they're invested. Let's get right. Invested in CoreWeave. They've opened their group model for robotics, open source that. They've invested in D-Wave. They're investing now in ABCI supercomputer. They are really putting their money to work.
They have some cash, don't they? So I guess
they have serious cash.
Makes a lot of sense. Makes a lot of sense.
And I would never have thought of Nvidia years ago, from the graphics card company, being this behemoth of, almost like taking over, aren't they? Like slowly maneuvering all over the place, like quite interesting. But anyway, getting back to just more from an investment perspective, but getting back to the supercomputers. Go on then, Lewis. Let's talk about qubits. Let's talk about how this really works. Let's figure out.
You're asking me
how super a supercomputer is.
I mean,
how many supers? What's the scale?
Like I actually understand supercomputing or quantum computing more specifically. Yeah, it's it's very bizarre because there's a lot of scientific articles saying quantum annealing is the thing that D-Wave's quantum
quantum annealing
devices actually do, and that's not the same as quantum computing. So at this point, I'm a little bit
lost.
Same. It's not the same. No.
I mean, they are different words, but what is quantum annealing?
See, I asked an LLM. I did a couple of searches just before, and
I thought you were an AI.
Yeah, I think actually understanding quantum annealing is going to take a little bit longer than a bit of research before the podcast. But quantum computing per se is an area that all the cloud computing providers, Google, Microsoft, are desperately trying to crack, because there are certain types of computing problem which are best expressed and dealt with by nature using qubits. I mean, if you can express it in a system which uses quantum effects to work things out in parallel, then you can find like a complex path for a route of options and do all sorts of very specific calculations almost immediately, where you can't with classic computers. So the promise is huge, and the AI involvement with GPUs is about working out how to do quantum computing and quantum research, rather than like somehow AI using quantum chips yet. So at this point, it's very much in the research space, and using AI to infer a quantum simulation on one side of research, and to also infer progress needed to better make quantum devices. So it's on two fronts, and those are lots of words all in a superposition that, if we measure, might just evaporate very quickly.
Well, let me just explain. This is going to make a lot of sense.
You tell me how quantum annealing works.
I'm going to read out exactly what quantum annealing is, and
did you refer to an LLM or a search engine?
I've just searched.
This is your head.
No, this is what it says it is. Brilliant. And it explains it really, really well, actually. Okay. It's a computing paradigm that basically uses quantum mechanical effects such as superposition, entanglement, and critically, quantum tunneling. What it does is it searches the energy landscape of an optimization problem for its global minimum. Instead of applying really a sequence of logic gates, which obviously you would have thought it would have done, like a gate model quantum computer, it slowly cools a quantum system from an easily prepared ground state towards a final Hamiltonian that encodes the problem of interest. So basically, there you go. I mean, not really much. They couldn't have put it any simpler, really.
I think that's basic stuff. I mean, I don't know what you're getting or complexities of quantum.
Honestly, I'm slightly embarrassed for you that you didn't know what it was now. I mean, it's so basic.
Although nearly all quantum physicists and physicists generally, when talked about the two theories of nature, one being the standard model, which obviously needs quantum understanding and quantum theory to be representing. It doesn't offer us any common sense, and unless you actually deal with the wave function and the maths involved, it's all a bit meh. I mean, basically, things can be in more than one place at one time, and they don't exist until you measure them, or do they? And the universe thing, black holes stuff, it's great.
Yeah,
that's my summary. Did my summary make more sense than the thing you read out, or less?
I kind of feel that might have made less sense than what I just read out.
That was called a human hallucinatory.
Yeah. Anyway, look, the point
quantum
being,
collapse
it's
state.
the ability to compute somehow, we don't know how, at a rate of knots by using qubits, which don't really fully understand exactly what that means, other than whatever a qubit ends up being, some superposition of something or other, something science. Anyway, basically, very powerful. That's basically the crux. That's how it translates down to people like me.
That's quantum computing.
That is quantum. That
Understood.
is the end of this quantum course. You can leave feedback at the end.
We might need it.
Yeah. But yeah, very, very interesting. I don't really know enough about it, how it works. I just know that obviously, like you were saying, the research is still happening. It's still very early days. I haven't quite managed to pin it down into anything, but it is obviously clearly Nvidia see an opportunity there on getting in on those advancements and making sure they're part of whatever the end result of that manufacturing of the chip ends up being in whatever future happens, really, when it gets to quantum, which kind of makes sense. So from an investment perspective, makes a lot of sense. From us mere mortals who don't understand what the hell is going on with quantum, we just see it as an investment. That's what we're summarizing it to be.
There's a lot of investment, but it's very unclear as to how long the play is. Is it like, I don't know.
And the cost in the end, what will be the cost to manufacture any of these chips, whatever they manage to,
well, at the moment, the chips have to be cooled to practically close to absolute zero. So although you may have a chip, it might only have a few qubits and might take up the size of a room and do just one calculation a day. But the calculation will be very fast. So it's hardly a practical device that you can put in your cell phone just yet.
So basically, the calculations will go absolutely off the charts in winter, and in summer we degrade down to the morons that we are. But in winter,
when I say absolute zero, I'm talking minus 240.
Oh, you're talking. I see.
Kelvin.
I see.
Not
Kelvin.
Not just a bit chilly.
Fahrenheit.
They need to be really.
Yeah, you're talking Kelvin.
Yeah.
Absolute Kelvin zero is what you're referring to.
Yeah.
Okay, fair.
Not a lot of movement of any atoms.
Well, anyway, on that bombshell of no information in the podcast, I think we should end it there. Obviously, there'll be another episode next week. We have a guest episode. I did an interview with Matt Griffiths as well, who heads up the cloud platform team for Phoenix Group, who kind of own lots of different insurance companies and such. So that's quite interesting. And we do talk about AI and the culture change that AI is probably going to have in the future to teams. Like, what does it mean to actually the engineering culture inside of a business? So we've got some hot takes there. So yeah, we'll be releasing that, probably this week or maybe next week. We'll see. So yeah. Cool. Well, let's get out of here and get some computing going, some quantums, some qubits. Let's go, Lewis.
Maybe not quantum. Bit very high.
All right. Maybe. See you all later.
Bye.
Bye-bye.